Hello dear students. Now I am going to discuss or solve the examples in your section, last section in the chapter 4.5, and this is very important part, especially for the exam and quiz, because you have two basic things: exponential and logarithmic and equation. So exponential equation and logarithmic equation. So in this section, our subject will be equation. You have an equation, and you know the equation. You have x and equality. The requirement is for finding the single real value of x is equal to what, as we did in the first chapter 1. So that's why we have exponential and logarithmic equation. So in the exponential function means that means that you have an equation like that. I am introducing this chapter for section for you. For example, I have 2 to this exponent 2 to power x is equal to 0. This is an exponential equation. Why? Because I have a x variable and equality and equal to something, for example 5. Okay, because you have equality and variable, that's why I have an equation, and because you have an exponential, that's why I say exponential equation. How about logarithmic? For example, I have log of 5 x is equal to 3. Now I have a logarithmic equation. Why? Because I have an x and I have a logarithm and I have an equation equality. So that's why I say logarithmic equation. First of all, we are going to deal with the first part of our exponent. So do not forget to isolate exponential to one side and leave the other side, and try to solve the logarithm. Try to take a logarithmic for both sides, and then solve for the variable x for the single. It seems that single variable x. We mean single x. I think you are remembering that single x means just x without square root, without absolute value, without square, without number, without division, without minus, anything. That's all we mean the single x. So I'm going to more clarifying our section by example 1. So in your page 128 in your lecture note, okay, in your lecture note. So the example is easy and basic for you, because you said the first time you have x3 plus 2 is equal to 7. Now in the exam, I say I have an equation and I have exponential equation because I have x and I have x3. That's why. So for getting the result of the equation, you can directly say we will take log to both sides. So I will get what? I will get log of equal to log of, okay, log of 7, as you know, and we have log of 3 x power to x plus 2, and you know we have a, b, c. So that's why directly I will say is equal to x plus 2 log of 3 is a number, and remains log of 7, again number. Now I can divide both sides by log of 3, forgetting just x. So I have x plus 2 is equal to what? Log of 7 over log of 3, right? Now, because they are numbered, just forget about getting the result. I don't want to really using the calculator here. So I have an x, I want an x, so this plus is going to the other part. So I will have, our next will be minus 2. So I got single x without any value. So I solved the first example by using the logarithmic, or by taking the logarithm to both sides. Now I have another example in the same page, example 2. 8 e to power 2x is equal to 20. Do not forget to follow these guidelines, because you need to use them as a part. So in this first part, see, isolate ex in the, or exponent in the one side. So I will say I have two e to power 2x, and I will divide 20 by 8. So, and you know, by 2 by 4 I will get 5, by 4 I will get 2. So e to power 2x is equal to 5 over 2. Now you see that take the logarithmic to the both side, and because I have a e, and if I have a exponential like that, I will use the log. If I have a e like that, I will use ln. Do not forget about that, it's better for you. So I am taking the ln to both side, and I will get what, you know, this is going to down by ABC. So 2x ln e is equal to ln 5 over 2. Do not try to distribute this one, because this is just number. You don't need the more details, more exercising, or more expanding. So, and I know ln of e by the property I have 1, so that's why I say 2x is equal to ln of 5 over 2. Okay, dear. Now, because I want to solve this exponential equation, just I want x, so I will divide ln 5 2 over 2. That's all, and you can leave it. Okay, dear, it's easy. Most of the parts are 2 over 5. You know, means that 5, if we divide 5, I will get ln of 2.5 over 2. That's so you don't need to do it like that. But if in case you see why in my lecture is 2.5, because it divided 5 is equal to 2.5. Now I am going to gradually, we have step by step, example by example. It's more complicated, so you need to more exercise. So please try to solve the exercises. So in the other example, in page 29, 129, in your lecture note, example 3, I have 3 minus 2x is equal to 4 again, and it's easy. Why? Because I have a exponential. I'll take them to both sides, as you know. So ABC, 3 minus 2x is equal, sorry, ln of e is equal to ln of 4. Am I right, student? Yes, sorry, yes. So 3 minus 2x ln e is equal to ln of 4. Now, and I know ln e is equal to 1, so that's why I say 3 minus 2x is equal to ln of 4. Now I'll bring the minus 2 to here, and I'll take this one, so I get what? 2x is equal to 3 minus ln of 4. Now, because I want to just x, I will divide both sides by 2, and I will get what? 3 minus ln of 4, okay, divided by 2 is equal to x. That's the value of x. That's all. I think it's easy for you. Now we have an important example here, which example of the quadratic equations form. How I know it's on the quadratic equations form. I'll use the other page because this example needs more work. Minus e to power x minus 6 is equal to 0. Okay, dear, this example needs more concentrating, so please be with me in the all steps. Step by step I am going to solve this form. If you change it to, for example, a square, if I say let ab e to power x, why I will change this one? Because you don't need to change this one, really. You don't need to say let, but I'll do this step for you to recognize, to know how about the form of this equation. This equation is of the quadratic equation, and you know the quadratic equation is at the form a minus, for example, bc or plus bc plus c is equal to 0. This is a quadratic form. So how I can I can imagine this form is like that. So let a be e to power x. So I will get what? A square, because if to make both square, you get what? If a equal to e to power x. Now I'll say I'll square both sides, and I'll get what? A square is equal to, as you know, by the first chapter we have e to power 2x. So it means that our equation, the blue one, is on the form a square, okay, on the form a square minus a minus 6 is equal to 0. So how you solve this one? How you solve this quadratic equation? As you know, it's easy to solve it like 2 bracket 0 a negative positive 3 2, and that's all. So if you want to solve e to x minus e to power x minus 6 is equal to 0, because I have an exponential equation, so I cannot use the ln directly to the other side like the previous examples 1 to 3. No, in the fourth one you should first try to solve this trinomial to this 3 term to the e to power x, like a e to power x, and I have plus negative plus. I have a 6, I have 3 to 0. I should change this one. This is just for clarifying, okay, clarify our steps. So in this example I just try to thinking about this example as a quadratic equation. So that's why we have what? We have something like that. Now I have 2 brackets are equal to 0, so I say ex minus 3 is equal to 0, or ex plus 2 is equal to 0. So it means that from here e to power x is equal to 3. So take ln to both sides. So you get what? You get x is equal to ln of 3. Am I right? Try to solve this one. Ln x coming to down, ln of e is equal to 1. That's why I will get the x in the left side and ln of 3 in the right side. Sorry. Now I have this one. I say e to power x is equal to minus 2. So I say this one is not, we will leave this one. Why? Because e to power x, it should be greater, it should be greater than 0. The value of e to power x should be greater than 0. You can imagine the graph. Here you cannot get the negative value or even the 0. That's why we say e to power x greater than 0 always. So in case in any example you face that e power x is equal to minus 2, means that maybe you made a mistake, or this is not our solution. So our solution is what? Is x is equal to ln of 3. That's all. If you are not understanding, please try to review or to look at the page 113 in your lecture note, and you can see the a square and all the details. That means it has no solution in this case, because the negative value, also you can see okay here has no solution because the negative value. Okay, and you try to solve 29. It's very, very important for you. Again, other part of last example in your section is if you have what? If you have 3x, it is that easier than the other one. Example 5, 113 in your lecture note. If you have 3x e to power x plus x squared e to power x is equal to 0. Now, and this is, I have a 2 term, so I cannot solve it directly, so I will take the x as a common, and e to power x again, so it remains x plus x. That's all that you have. Okay dear, so I took the x as a e to power x as a common between them, and x between x and x squared. That's why we got just this one. So I have a, b, c is equal to 0, means that x is equal to 0, or e to power x is equal to 0, or 3 plus x is equal to 0. We will cancel this one. Why I canceled this one? Because we say e to power x is should be greater than 0. That's why in this case, if I have equal or less, we will not accept this one. We say we has no solution. Sorry for the recording example like that. And x is equal to 0 or x plus 3, so I will get x is equal to minus 3. So my solution is x is equal to minus 3 and 0. That's all. And you can see the example and the solution. So let's try to solve the other exercise. This is the part of logarithmic exponential function, as I mentioned in the first in the beginning of the section, that in the 4.5 I said that we have exponential equation and logarithmic equation. So we finished the first part of this session. Next I'm going to deal with the logarithmic equation. So in the logarithmic equation, we have in this part, we have logarithmic equation, means that, as I mentioned, logarithmic with the x and equality. So your duty is what is finding the single value of x. So how we solve this one is very easy. Just pay attention. For example, if I have log of 2 the base 2 x plus 2 is equal to 5. So I am taking my focus on the base. Okay, my focus will be on the base. So I will raise up this equation into 5. So I'm write down again 2 x plus 2 is equal to 5. I say I'll raise up the equation into the power 2y, because I have 2 here, that's why. So, and you know this example, this exponent with the log, they are eliminating each other because they are inverse to each other. So for inverse of each other, so I will get x plus 2 is equal to 2 to power 5, and you know 2 to power 5 is equal to 32. So I say so I will get what? X plus 2 is equal to 32. So they eliminate each other. 2 log of 2 for anything, they will eliminate each other, and I will get just this part. So in x plus 2, I got x plus 2, and 2 to power 5 means that's 32. So I will get minus 2, and finally this is my solution. Maybe it's not easy for you. The first example, I'm going to put next page 131, and we will try to solve the examples. Before you try to solve, please read the guidelines for you that mention the basic or important points for you. Isolate logarithm in the other part, in the left side, and try to write equation and try to raise to the base, okay, the other side, and solve for the single x again. Now I'm going to solve the example 6 in page 131. So example 6 page 131, your lecture note, as every time I mention this one. So if part A, you have ln of x is equal to 8. Now I have no logarithm, so how I raise up this one? You know the base is e, so try to write e to both sides, and they are eliminating this part, so I get e to power 8. That's all, okay dear, and you can try the solution. You can see the solution. How about part B? So the usual one, 2 25 minus x is equal to 3, because I have x, the base is equal to, so I am raising up both sides to 2, and they are eliminating each other. So I got 25 minus x is equal to 2 to power 3. So x is equal to what? X is equal to 25 minus 8, and x is equal to 25 is equal to 20, 17. That's all. Okay, dear, that's all. So here's your solution. You can try to solve 37 and 41. How about the other example, example 7 in your lecture notes? So I'm going to step by step, or I will try to leave this example for you. I don't think it's difficult, so I will leave this one as a homework for you. Try to solve it at home, but not assignment, it's homework. So homework means that just do it for yourself. So I'm going to the last part or last example. Let me see if this example has got anything. No. So this type is very important, and try to solve also the example 49. And before I am going to solve this one, I want to tell you this part graphical solution are not included, so just we will use it by one method, the algebraic method. And be careful, this example is very important, and there is something important as a note for you in the solution. So solve the equation. I have log of x plus 2 plus log of x minus 1 is equal to 1. Do not forget about to follow for solving, follow the guidelines before you are solving this one. You see that isolate a log in one side and let be the other part in the other side. So how can I isolate the log? And you know, because I have a 2 log and addition, because I have a 2 log and addition, I can see I is equal to something multiply something else. So I have x plus 2, x minus 1 are equal to 1. And because I have a log, and you know, when we wrote log, if I wrote just log, means that the base is equal to 10. So if I wanna eliminate this log, means that I should write this example, this part into 10. Okay, dear, you know why. So x plus 2, x minus 1 is equal to 10 to power 1 is equal to 10. So I am going to solve this example as a quadratic equation. So I will multiply this one. We need really, for the, if you don't know how to do this step, you should review the chapter 1. So we will get x squared, x by x, and minus x plus 2x minus 2 is equal to 10. Now I'll bring the minus 10 to the other side. I'll get what? Plus x minus 2 minus 12. Okay, dear, is equal to 0. Now I got a quadratic equation, so I'll change it to, and they are trinomial, to x plus minus, I have a 12, so 4, 3. Okay, dear, so x is equal to minus x plus 4 equal to 0, then x is equal to minus 4, or x minus 3 is equal to 0, then x is equal to 3. And here's the note, here's my note that I mentioned in your lecture note. I see here's an important note. You should check the value and put it here. If you get negative, you should throw it. If you get 0, you should neglect it. If you got this positive, this is your solution. So if I put minus 4 in my base equation, I will get what? So let me try. log of, okay, x plus 2 plus log of x minus 1 is equal to 1. If I put minus 4 here, I will get what? I'll get log of minus 4 plus 2, which means that log of minus 2 is not acceptable. Why? Because log of x here, x should be greater than 0. Even 0 is not allowed. So log of just we will accept positive value, no 0, no negative. Okay, dear. So as we have a note in the exponential that should be greater than 0. So also here we have a important note. You should be careful and notify that this in your lecture note. How about if I put 3 here? So x plus 2 plus log of x minus 1 is equal to 1. So if I put 3 here, I'll get what? Log of 5, log of 2. So it means that x is equal to 3 is my only solution, because it's acceptable and there's no problem if I put things. That's why it's not in your lecture note. I see you have a note. Listen and read. We check the positive original equation and find that x minus 1 is not a solution because the logarithm of negative number are undefined, even 0 and also undefined. So but x is equal to 0 is equal to 3 is a solution, and check your answer. That's all in your this chapter. I hope you are understanding and studying this only section, because in the exam you will find one example of the exponential equation, and also you will find the other logarithmic equation. So that's all, and have a nice time. Thank you.